Let's go to LeetCode number 1063, number of valid subarrays. For this question, to give us integer array nums, return the number of non-empty subarray with the leftmost element of subarray not larger than other elements in the subarray. So let's look at the example. You'll see for one, right? One, we can the subarray which start with one that can be 1 4. 1 4 1 2 1 5 and 1 3, right? So because we didn't find a number after 1 that is smaller than 1, so it can form from this I to a minus 1, right? But for 2, right? For this 4, you'll see the next element is smaller than 4. So we only have one element, one subarray. And then let's look at the 2, right? 2, we can have 2, 2, 5, and then 2, 3, right? And then 5, and then I have 5 because the next one is smaller than 5, right? And also 3, right? So we'll see 1 1 4 1 4 2 1 4 2 5 1 4 2 5 3. So let's see what we want is to calculate those kind of subarray counts, which is the first one is the biggest one, right? So what we're thinking about is, for example, an array AI. We want to find the number after this, which is smaller than, for example, AJ smaller than AI, right? So how many subarrays start with AI? That is J minus I, right? For this one, some of number they cannot find a number smaller than it. So we can so for this question, intuitively we think about that is monostack problem. Some number, if we cannot find a number smaller than it, then we can add for example minus 1 to the end, right? So that is some kind of technical about monotonic stack, because the number range is from 0, right? So let's begin to write code for this. Actually, we'll have int n equals nums dot length, and we'll have stack back integer stack plus new array stack. So as we mentioned, we can have a result plus 0. We just have one more index in I equals 0, I small equal to n I plus plus, right? So what we are in the value equals, for example, this I equals n, then we'll have minus 1, otherwise we'll have nums I, right? So we'll say if this value is smaller than the index which points to the value which is in a stack, we just keep in pocket, right? Stack while stack is not empty, right? It's not empty. And stack pick something, we're doing something, right? So in the end, what the stack need to always push this index. So if we put that index, then we're trying to compare the arrays number, right? If this one greater than value, then we are going to have in the index equals stack dot pop. So what we are going to do is that result plus equal to I minus index, and we just return result, right? So This is time complexity will be ON, strength complexity will also be ON. We actually in my previous some of the videos we talk about we can use an integer array to simulate stack. We have a stack equals new int n plus one, right? So we have index minus one, and so the same thing here, right? So let's say while this index we have this index, and while this index is greater equal to 0, that means there we already this pointer pointed to some element, right? So this is not then we'll have this index plus equal to this, and we'll have instead of use push, right? We just move the stack plus index plus. So we can use an array to simulate stack. While numbers, this will be stack index. Okay. So this is the same as what we do using a stack, right? So so also this one, this index is different. We should have stack index. Okay. And when we pop, right, we'll have index minus. We need to pop some kind of value. Okay. Doing like this, the time complexity O and space complexity will also be O.